Hello, everyone. Welcome to the Daily Space. I am your host, Dr. Andres Plazas, and today we're going to talk about space news. So, for the first story of the day, we're going to talk about Mars, as you can see from the picture on your screen. So, we're talking about the Curiosity rover that recently has provided a new panorama of the site where it is actually, and it's very close to the location of a geographical feature that is called the Vera Rubin Ridge. So in this panorama that we're gonna see later, the rover, well, you can see that the darkened skies because of the fading global storm that is actually affecting Opportunity, but Curiosity is still working. And you can also see some of the drilled targets that Curiosity has been studying. So actually, in the screen, in the lower right, you can see one picture of those grilled targets that the rover has taken. So this, what is this ridge? This Vera Rubin ridge is also known as the hematite ridge. It is a linear topographic feature that is parallel to the foothill of the perimeter of Mount Sharp in Gale crater, which is where the rover is. It is about 250 meters wide and extends a lot for about 7 kilometers. And there are still a lot of questions about why do we have this geographical feature there? Why does the Vera Rubin Ridge exist in the first place? So some of the scientists from the mission from JPL, they point out that this ridge is not a monolithic thing, actually. It has different sections with different types of colors, and even some of these sections can be seen in the visible part of the spectrum, but some of them actually you have to look at them in the infrared. And some of these features actually could be related to how hard the rocks in this ridge are. So this is one of the mysteries that they want to figure out, like also about the composition of this particular ridge and why the rocks in it are so hard. So one of the best way to discover why these rocks have this composition and this strength is to drill them, and then the rover puts the powder resulting from the drill into some of the internal laboratories that it has. It has some instruments or laboratories that it has on its deck. And then the scientific team actually hopes that analyzing these samples, it might reveal what's acting as what they call the cement or the glue in the ridge that is actually providing the hardness to the actual ridge and preventing it from being eroded with time. So the researchers said that maybe, or most likely, it is groundwater that was flowing back in the time in the ancient past that maybe had a role in strengthening it, like acting, for example, like a plumbing to distribute this type of whatever is holding that ridge together, this type of cement, or what they call the wind-proofing cement. Another thing that they point out in this press release is that a lot of the ridge contains hematite, which is a mineral that forms in water. There is such a strong hematite signal actually coming from this ridge that it drew the attention of the NASA orbiters, almost like a beacon, they say. And then some questions arise. Then they say, could some variation in hematite result in harder rocks? Is there anything special in the ridges red rocks that makes them so unyielding? But for the moment, it is still a mystery. These questions are still a mystery, and this composition of this ridge, the Vera Rubin Ridge, it's one of the objectives that the rover wants to figure out. So to conclude, the press release lets us know that there are 2 more drill samples that are planned for the ridge in September. And then after that, Curiosity will drive to It's one of the scientific zones, the areas enriched in clay and sulfide minerals that are higher up in Mount Sharp in the crater. And that ascent of Mount Sharp is planned for early October. So as I mentioned at the beginning, they produce a panorama that you can go on YouTube, actually, and I'm gonna just show a little bit of it because it's pretty cool. If you're on your computer, you can just let the video go, and as the video advances, like, you can just look around. You can just drag with your mouse, and then take a look from the vantage point of view of the rover itself. You can see Mount Sharp in the back, and then they tell you the features, right? Sorry, they tell you exactly what the features are, and I think it's something pretty cool that I encourage you all go and take a look. You can see the deck of the rover, a little bit of dust on the rover. You can see some of the instruments, the came in inlet, at SAM inlets, where you put the dust, the robotic arm, some sediments. So yeah, so it's a pretty cool panorama, and you all should go and check it out. So yes, I just wanted to let you guys know of that. So this is on YouTube. You should just go to the channel of JPL, NASA Jet Propulsion Laboratory. All right. For the second story of the day, I wanted to talk about ALMA. So in this story, the researchers report that ALMA in Chile has observed what they call the most distant galactic wind outflow. So astronomers of the ALMA of the array, they have used the technique of gravitational lensing as a cosmic telescope to detect the most distant galactic wind of molecules ever observed. And this is seen when the universe was only about 1 billion years old. And the way they did it is by tracing the outflow of a certain type of molecules. These are hydroxyl molecules, oxygen and hydrogen, which tells us about the presence of a star forming gas in galaxies. So this is a result that provides insights in how certain galaxies in the early universe were able to self-regulate their growth, so they could continue forming stars across the cosmic time. And then, well, the researchers of this study, they point out that, well, galaxies, of course, we know are complicated in general, right? And researchers think that this type of outflows and winds are critical pieces into how galaxies form and evolve, and they actually regulate the ability that galaxies have to grow. So astronomers, of course, in the past, they have observed winds of the same size and speed and mass in other starbursting galaxies, galaxies that are forming stars. But the particularity about this ALMA observation is that it is the most distant, unambiguous outflow ever seen in the early universe. This is a galaxy that is known as SPT 231955, so some number, but it has the letters SPT, which means that it was discovered by the South Pole Telescope. And this is a galaxy that is more than 12 billion light years away. So, as I mentioned before, ALMA was able to observe this object at such a high distance because they use the technique of gravitational lensing, which because there is another galaxy that is sitting actually in front of this background galaxy, and this galaxy is acting like a gravitational lens. So you're going to see the background galaxy distorted, and then you're going to see it magnified, and then you're going to see all these effects that are analogous to what you find in regular lensing by a piece of glass, and hence the name. However, there are certain differences, like in If you have a regular lens, you're gonna see that you have different distortions depending on the wavelength of light. However, gravitational lensing is independent of light, and that's why it also works with an observatory like ALMA, which is actually producing light, detecting light at submillimeter wavelengths. So then astronomers are going to see these distorted galaxies, and they're going to see multiple images, and that's what you can see in that inset in the left part of the picture of your screen. The right hand side picture is an artist's conception of these winds, of these outflows, of these outflows of these winds. But the left one is the actual it's an optical image plus what ALMA observed. And then, as I was saying, astronomers, they have all these multiple images from gravitational lensing. And then if you assume a certain mathematical model for the actual lens, then you can walk your way backwards and you can de-lens the image. And then you can trace back those multiple images to their common source because they have that constraint. And that allows you to obtain an image of the actual original source. Of course, then you're introducing errors because there are assumptions in your, of course, there are errors in your measurement, but there are also assumptions in the model of the lens itself, of the galaxy lens. So, a little bit of more details of the discoveries that these galaxies were detected actually in the millimeter, but at those distances, actually, the image, the light that was emitted was in the infrared. And then, because of the expansion of the universe, this type of light has actually extended, and then you need a detector that has sensitivity in the millimeter to be able to see these images. But what they actually observe is the absorption signature from this oxygen and hydrogen molecule that I was telling you about, these OH molecules. So hydroxyl molecules, yeah. So and then to conclude, the researchers point out that so far they have only observed this type of galaxy, this one galaxy at such a remarkable distance, but they would like to know if this type of winds are actually also present in other galaxies to see how common they are. So then, as I was saying, these type of winds are important to regulate and to provide feedback into the galaxy of the star formation processes of the galaxies. So yeah, that was very interesting, very cool to see such a distant galaxies. But then for the last story of the day, now we're gonna switch a little bit in wavelengths. We're still in the electromagnetic spectrum. I imagine that in some years from now, hopefully, I don't know when, we're gonna have on the daily space news about gravitational waves and then different parts of the spectrum of the gravitational waves spectrum. That would be pretty cool. For the moment, we're still with the electromagnetic spectrum, some traditional astronomy. And this final story of the day is related to images taken in the X-ray, taken by the NASA's Chandra X-ray Observatory. So this observatory actually has discovered a ring of black holes or neutron stars, it could be, in a galaxy of about 300 million light years away from the Earth. And that's those purple dots that you can see in the image on your screen. Those are the X-ray emissions of these compact objects. So the image that you're actually looking at in your screen is a composite image of a particular galaxy. It's called AM0644. And as I was saying, the data from the X-ray Chandra telescopes are depicted in purple, whereas the optical data taken with the Hubble Space Telescope is depicted in the usual colors, combinations of red, green, and blue filters. And the interesting thing is that this Chandra data reveals the presence of very bright X-ray sources. And as I was saying, they're most likely binary systems powered either by a stellar mass black hole or a neutron star. And they're all located in a ring alignment. So actually, we can also see the X-ray only data and the optical image. So I'm flipping right now through all these images. This is the composite image, and then you have the X-ray sources in purple. You can see they're located mainly in a ring. You can see also some sources at the center of the galaxy, but there are also some other sources outside of the main galaxy. But for now, we're focusing on why these galaxies are actually located in this particular geometrical alignment. So, well, astronomers, as to answer for these questions, astronomers think that this array of galaxies located in a ring, it was created because there was actually an interaction with another galaxy, and they think that the galaxy that you can see on the left lower corner of your screen is the other galaxy with whom the original galaxy, the one on the right, interacted. And then they think that the gravity of one galaxy was pulling the other galaxy, and then this first galaxy generated ripples in the gas of the secondary galaxy, this AM0644 galaxy that is located on the right. And then these ripples then produced an expanding ring of gas in this secondary galaxy that triggered the birth of new stars. And then the most massive of these stars that were formed by this trigger formation, actually the more massive a star is, the shorter it lives. So in terms of cosmic years, of course, it's only a few millions of years. And then after the nuclear fuel of these massive stars is spent, then they explode as supernovas, and then they either leave behind a black hole with masses about 5 to 20 times that of the sun, or you have neutron stars that have masses approximately equal to the mass of our sun. So they don't know exactly if there are only black holes of neutron stars, but they think that they're either black holes or neutron stars. And then they say that in addition, some of these stars have companion stars that are very close to them. And then these black holes and neutron stars, they siphon the gas or the material from this other companion, and then you have this gas that is falling towards the black hole or the neutron star, then forms a spinning disk, and this is a disk that becomes heated by friction, and this is actually what produces the large amounts of X-rays that Chandra can detect. Then to finalize, they point out that this is already intriguing in and by itself, like this geometrical configuration of rings. But then they point out that these sources, X-ray sources, are bright enough to be classified as what they know, astronomers know as ultraluminous X-ray sources, like ULXs. So this is a type of object that produce hundreds to thousands of times more X-rays than more normal binary systems, where you have these companion stars between a companion star and a black hole or a neutron star. And it's still a mystery for them, like why this is the case, right? Like the identity in this particular case, the identity of these individual ultraluminous X-ray galaxies is currently unknown. And as I was saying, it could be a mixture of black holes and neutron stars, but it could be entirely that they're all just black holes or all just neutron stars. And yeah, so that's all what I have for today, these 3 stories. I like to flip between these optical data and the actual final data. But yeah, as usual, I'm gonna see what all of you have to say and to comment. I'm gonna go back to the chat and let's see what you all have to say. So I already said hi to Fenric, Larry, Adam, Guido. There's Susie. Hello, Susie. DPI. Ironheart. Tom. Happy Friday. Yay, it's Friday. Graham. Did anyone watch the interview with Elon Musk? I haven't watched that. I read about in the news about it. Um, Alaman points out that curiosity is drilling holes again, and the Gale crater golf course will soon be complete. Yes, that's why we do space exploration. We want to create golf courses. Hello, Hanis object verb. Hello, hello, Star Strider. Thank you so much for joining. It is my honor. Hello, Graham. There shouldn't be. So Hanis object is telling us that there shouldn't be any chromatic aberration caused by gravitational lensing. Yes. Then Han is also asking, would galactic wind only be observable from younger galaxies? That's a good question. I don't have the exact answer to that, but I would think that shouldn't have to be necessarily the case. I would find maybe it is more likely because you have this formation in all these younger galaxies. And we were saying that this wind is probably triggered by explosion of, I don't know if I mentioned it, but this wind is probably triggered by explosion of supernovae, or another hypothesis that they say is that it could be a gas infalling into a central black hole of the galaxy or something like that, that is triggering this type of winds. So I would think that then yeah, maybe you'd find them more frequently in these younger galaxies, but not necessarily. Would this wind be a major part of reionization? Yes, I mean, reionization is caused when you have this, then of course we're back in the Big Bang, then we have the seeds of the Big Bang in the CMB, and then there was a point in time when you only have these clouds of gas, of cold gas, that started to collapse, and it takes time to do that. So that's what is called the dark ages in the universe. And then after that, then you start finding the stars that grow and then explode, and then you have, because of the radiation of the stars and then actually the explosion of the stars, then you find that the other molecules start to be ionized. So it's called the reionization epoch of the universe. So this would be part of it, this type of activity and stellar feedback or the stellar activity. But reionization actually starts when the stars themselves begin to shine, even before they exploded and produced this type of wings. Hani subject points out that there is so much stuff in the visible in comparison in the last point. Yes. Could that interaction with the other galaxy lead to the galaxy on the right becoming a spiral? Actually, I think it was the other way around, that you have these spiral galaxies that you started merging, and then actually you introduce like more disorder in the system, and then I don't know if they become elliptical or not. I'm not particularly sure about that. So yeah, that's a good question. Then like the X-ray binaries that Dr. Gay talked about a couple of days ago, and Dr. Gay herself answered yes, because I'm not sure, but yes. Okay. Okay, do you guys have any more comments, any more questions? I hope that the stories were interesting, but at the same time that you had good audio quality, and everything went smoothly. As I said, this is the first time we're trying this new configuration. Then in about half an hour, there's going to be a press release regarding Dawn, regarding Vesta and Ceres series. I say series, I think it's series. Anyhow, Initially, I was the one who was gonna comment, but now it's going to be Dr. Pamela Gay who's going to give us a commentary on this press release. So hopefully, I can do it in the future, and you can hear me talking about this, which sounds pretty interesting. But if you don't have any more questions or comments, then I think we can call it for now, at least the daily space. And then, as I said, please don't forget to come back in about a half an hour to know more about Dawn and Vesta and Sirius. Well, thank you so much for watching, and this has been the Daily Space, a production of CosmoQuest and the Astronomical Society of the Pacific. Uh, we appreciate enormously your support, so please give us a like, give us a follow, make some noise with your friends in social media, tell everyone that we talk about science every day here on Twitch. And we'll come back next week, now the regular time. The Daily Space will come back every day of the week at 1 p.m. Eastern Time in the United States. And okay, so have a great weekend, everyone, and see you next week. Adios. Bye bye.